Welcome back. We're in lesson 58 and we are going to find the distance between a point and a line. So let me give you an illustration. If we have a line here, let's say we have a line going in this direction, right? And we have a point out here somewhere. We can find the distance between that point and that line by first finding the perpendicular slope of this line. Let's call this A, and we'll call this point B. So we can find the perpendicular slope of this line, which would create a 90-degree angle to this line, right? And then we could find the intersection with that line through its perpendicular point, which would then allow us to find the distance between these 2 points, which gives us the distance between this point and this line. So let's just jump into an example problem to see how that works. So we're going to jump into 58.1. Let me put that up here. We're going to find the distance between this point, -3 and 5, and this line, y is equal to 1/2 x plus 1. So first we'll find the equation of the line through the given point that is perpendicular to this line. So we're going to find the perpendicular line here equation. So that's going to be y is equal to, now this is going to be the reciprocal and the opposite. So that's going to be a -2x plus b, because we don't know what that intercept point is. And then we're going to sub in this point here. So that's going to be 5 is equal to -2 times -3 plus b. So 5 is equal to 6 plus b, so -1 is the value of b. So that allows us to rewrite this line. Now we can say y is equal to -2x minus 1. That's this line right here, our perpendicular. This was our perpendicular version of this line, right? So now we have the perpendicular line that, here was our original line, right? So this is, here's that point, whatever it is. Here's the perpendicular line. We just created that perpendicular line that is this one, right? That's this right here. All right, so we see that. Now we're going to use substitution to find the intersection of lines A and B. So we're going to set them equal to each other. So this was step 1. Find the perpendicular line that goes through that point. Okay, perpendicular line for the given point. Right? Step 2. You would think I'd be able to spell step at this point. I'm going to circle this so you can see it. Step 2, we're going to use substitution to find the intersection of lines A and B. So we're going to say this line, which is 1/2 x plus 1, is equal to this line, -2x minus 1. So that's our substitution. All right. So now we are going to multiply everything by 2 to get rid of this denominator. So this would become x, oh, and what did I forgot my 1, it's plus 1, plus 2 is equal to -4x minus 2. So now we got rid of our denominator, so it's just easy to deal with that. So I can subtract 2 from both sides, and I can add 4x to both sides, and I get 5x is equal to -4. So x is equal to -4 over 5. So now I'm going to substitute that back into this line. So that would be continuation of step 2. So y is equal to -2 times -4 over 5. Booyah, minus 1. So that would be negative 8 over 5, or positive 8 over 5. Y is equal to 8 over 5 minus 1. Well, in this case, 1 is going to be 5 over 5, right? So y is equal to 3 over 5. So our other point is going to be negative 4 over 5 and 3 over 5. That is our intersection point. Now we can use the distance formula, and we're going to reduce this down to decimals just to make the math a little bit easier. So this negative 4 divided by 5, that's going to end up being negative 0.8, and 3 divided by 5 is going to be 0.6. So there's that. So now we're going to use the distance formula. I'm going to scooch this up just a little bit so we have room for it. Or maybe I'll go over a little bit. I'll go over. So step 3, actually this was step 3. Step 4, that's going to be the distance formula. So distance formula to find the distance, finally, now that we have those points. So our original point was negative 3, 5, and our intersection point is negative 0.8 and 0.6, right? So now we can put those in. The distance is going to be equal to the square root of, we have negative 3 minus negative 0.8. So that's going to be plus 0.8 squared plus 5 minus 0.6, and that's going to be squared. So then this is going to be square root of negative 2.2 plus 4.4 squared, which is going to be, I need my calculator. Hold on. I'm getting my calculator. My brain doesn't do all of the decimal stuff. I could probably do it if I thought about it long enough, but I know you guys want to get through this lesson without taking tremendous amounts of time. So let's just use a calculator. And it's actually recommended to use a calculator anyway. So 2.2 squared, and I'm not going to worry about making it negative because negative times negative is positive, right? So that's going to be 4.84. So 4.84 plus, and then we've got 4.4 squared is 19.36. So 19.36. So I'm going to add them together. So plus 4.84. And that's 24.2, square root of which is 4.919, and then it drops down to 3, so I'm going to round this to 2 decimals, 4.92. So the distance is equal to 4.92 units, whatever those units are, and that is the same answer that the book has. We figured it out. That's what you're going to do. So let's go back over our steps so that you know how to do this. First of all, step 1, we take the line that we're given, which was this one right here, right? These were our givens. And then we find the perpendicular version of that. And the perpendicular is found just by getting the slope, and that would be the reciprocal times -1. That would be how we find the perpendicular. And we have to change the b because it's not the same line anymore. We just know it's perpendicular to that line. So only thing we really know is the slope. So then we take these points, we sub in our points, or we sub in our point, and then that is going to give us the value of the b, which then gives us the perpendicular. This is the perpendicular line, which is right here. Now that we have the perpendicular line, we're going to use substitution, and we are going to set this original line equal to the perpendicular line. We're going to get rid of our denominator and just solve for x. So now we are going to, and the reason we can do that is because we have y is equal to this, y is equal to this. If both of those are equal to y, then this one is equal to this one. That's the logic, right? Okay. So then that is going to give us our value for x. We'll turn around and take our perpendicular line. This is the perpendicular line, and we're going to solve for y. So we solved for y, which gives us the point. And then I just reduced it to a decimal. You could have used fractions, but then you would have had to convert the original point to a fraction once you did your distance formula. So it's easier just to use a decimal in that regard. And then we just used our distance formula to solve for the distance between the 2 points that we figured out. That is the process. All right, so let's do one more, and I'll try to be a little bit more organized when I do this one. All right, so here's 58.2. We have a point and we have a line. Step 1. I'm trying to be more organized this time and not be all over the place. Step 1. We get the perpendicular form of the line here. So the perpendicular line is going to be the opposite reciprocal slope. That's how you get a perpendicular. So that is going to be y is equal to a positive 3x plus b. Now remember, it's a perpendicular line, but we don't know where it intercepts, right? We just know it's perpendicular to this one. So the only thing we can do is change the slope to its perpendicular and then have our 2 variables, or our 3 variables here. Now we are going to substitute to solve for the point of intersection. So here's our point, and we're going to figure out where it intersects here. We're going to sub in the y and the x values. The y is 5, and the x value is -1. And that's going to give us our b value, which is going to tell us what the line is equal to. So let's do that. Let's look at, that's going to be -3. We're going to add 3 to both sides. So 8 is going to be the value of b. All right, so there is our b value. So now we can rewrite this line. So step 2 is going to be y is equal to, this is step 2, y is equal to 3x plus 8. So we took that and rewrote that perpendicular line that way. All right, so now we are going to set this line equal to this line, because y equals this and y equals this, so we can sub in whichever one we want for y. So we're going to bring -1/3x plus 4, set that equal to 3x plus 8. We're going to multiply everything by 3 so we can get rid of this denominator, right? So 3 times -1, that would be a -1x plus 12 is equal to 9x plus 24. Now, if we combine everything, we are going to get a -10x and a positive 12, which if we divide, gives us x is equal to -1.2. Let me go ahead and just put that step up there just so everybody can see it. So -10x is equal to a positive 12 because we subtracted 12 from both sides, we subtracted 9x from both sides. So then when we divide, we get x is equal to -1.2. All right, we just went ahead and did the decimal just to make life easy on ourselves. So now that we have the decimal, the value for x, step 3, we're going to find our point So this is going to be substitution. Or let's just call it what it is. Set both lines equal and solve for x. That's what we did in step 2. Step 3 is we are going to find the point by subbing in for x. By subbing x. So here's our line again. Y is equal to 3 and our x is negative 1.2 plus 8. So we do the multiplication and we get negative 3.6 plus 8. Y is equal to 4.4. Okay. So now we have our x and our y. So we have our original point here, which is negative 1 and 5, and our new point, which is negative 1.2 and 4.4. Those are our 2 points. Now we're just going to use step 4. I think I skipped a step somewhere. I think the last one had 5 steps. Now we're going to use our distance formula. So the distance formula is the last step to find the distance. So we are going to set D, that's our distance, is equal to, and we have negative 1, and that's minus a negative 1.2, so that's going to be plus 1.2 squared plus 5 minus 4.4 squared. This is a 5. It looks a little bit like a 6, so I'm fixing it. Sometimes my pen doesn't actually do what I want it to do. There we go. That looks like a 5. All right, so now we're going to do the math and square those. So this is going to be 0.2 times 0.2, which will be a 0.04, I believe. I think I'm doing that in my head, right? So 1 negative plus 1.2 equals 0.2, and we square that with 0.04. So this is equal, by the way. Distance is equal to the square root of 0.04 plus, and let's find out what this one is. That's going to be 0.65 minus 4.4 squared, 0.36. So 0.36, which gives us 0.4. So the distance is the square root of 0.4. So let's do that here. So plus 0.04 is 0.4. The square root of that, it's not what I thought it would be. 0.63245, whatever. We're going to reduce that to 2 decimal places because that's our standard precision, and just say 0.63. So the distance is equal to 0.63. Whatever the units is on that. We don't know what the units are. And that would be your answer. All right. Okay, so that's all we have for 58A. So do a couple of those practice problems, and then we'll get into 58B, which is talking about narrow and wide parabolas.